In this case, we're looking at what you call an RL circuit. And just to make things clear, um, let me hit focus here real quick. Let me try to refocus that. That's much better. An RL circuit, R stands for resistor, and the L stands for obviously inductance, right? So we have here an RL circuit. Now, how do we solve these circuits, right? So obviously we'll have a VS here, okay? And if I give it, for instance, if you have something like, well, VS is, we get an example, 120 cosine, omega t plus, let's say, 10. What does this mean, and how do we solve this problem? Okay. First thing we want to do when we solve these problems is obviously we want to start here and work half the page, right? So the first thing we want to do is get our values. Okay. And our starting point we'll have, first thing we want to do is you want to go ahead and translate what this 120 and what this 10 degrees mean, right? So we have basically our polar coordinate here is 120 at 10. Okay, that's 120 volts at 10. And obviously this is going to be volts. Okay, now this 10 is our angle. Now the next step is to get all these values, okay, grab them quick. But these values have a little different. So your R value is going to be obviously 100 ohms, right? Our L1 value is 100 milliohms, which is what? I'm sorry, 100 millihenries, which is 100 times 10 to the third. I'm sorry, 10 to the minus third henries, which gives us a value of point, right? If it's 100 millihenries, you go 1, 2, 3, 0.1, obviously 0.1 henries. Okay. Our L2 is simply 200 millihenries, okay, which is 200 times 10 to the minus 3 henries, which is 1, 2, 3, moving over 0.2 henries. Okay, so now we're ready to set up the problem. So this is the first step you want to handle and get everything to its basic form. Then understand we are delving in Z's. Okay, we are now in Z form. So this is Z, this is Z, this is Z. So convert everything to Z. So ZR is going to be what? 100 ohms, right? Z of L1 is going to be what? J omega L1. Z of L2 is J omega L2. Okay? Now, we know what L1 and L2 is. We've got to figure out what omega is, right? But omega is very simple. Any AC circuit, this is our omega here. It's the same omega that translates across all the resistors and all the impedance and all the inductors and all the capacitors. So omega is always 2 pi f, okay? And in America, if we're looking at our f is always 60 degrees. I'm sorry, 60 hertz, okay? So let's look at this very clearly and how this works. We'll bring a calculator side by side. You want to turn on your calculator. You need a basic scientific calculator. So your 2 pi f times 60 is omega times 2 times 3.14 times 60. Okay, so omega is 2 times 3.14 times 60, which is 2 times 3.14 times 60, and we get, let's take care of that real quick. Why is that a negative sign? It should not be a negative sign. Get rid of that. 376.8. 376.8 is your number. Okay, so now what you do, you simply plug it in. Z of L1 is J 376.8 times your L1, which is 0.1. Z of L2 is J 376.8 times L2, which is 0.2. Once you're here, once you're at this position, okay, the problem is very simple. Okay, so what we'll do is we're going to go ahead and write this out and say 376.8, since you're already here, multiply that by 0.1. If you can do it in your head, great. You get 37.68, just like the calculator. And Z of L2 is going to give us 376.8 times 0.2 gives us 75.36, J 75.36. Okay, so that is your impedance values. Now, over a period of time, you know, what you want to do is do a series. So now, all these circuits here are obviously in a series here, right? So make things easy. What's a series? Well, series is you add R1. So if it's a series circuit, R1 is equal to R series is equal to R1 plus R2 plus R3, so on and so forth. So if this is in a series, you just write Z equivalent is really a series. I'm going to write down series, okay? And that series is equal to Z of R plus Z of L1 plus Z of L2, okay? So how does that work? You simply add them. 100 plus J 37.68 plus J 75.36, okay? And that's a J. All right. So how does that work? You simply add the numbers together. Z equivalent here is 100 plus these two J's. Okay, so let's add the two J's up. 37.68 plus 75.36. Okay, which is J 113.04, and that is ohms. Okay, so these are all ohms. So the henries transfer to ohms. When you type in j omega, it becomes an ohm. This henry here becomes, when you multiply j omega, it becomes an ohm. That's why you have impedance. That's the value of impedance, okay? So this is the part 1 of our video. Part 2, we will show you how to handle the current calculation from here, okay?